Aloha and welcome to ICS 314 and 613, Software Engineering. My name is Philip Johnson. I'm going to be your host for this semester. I'm hoping it's going to be a fascinating, provocative, mind-boggling introduction to world-class software development tools, technologies, and practices. So without further ado, let's get started. Okay, some preliminaries. My email is johnson@hawaii.edu, also philipmjohnson@gmail.com. The website for the course is a Google Sites URL. My email and website are going to be emailed to you in various places, so you don't really have to copy it off this screen. My office is in the Post Building, room 307A. That's the CSDL suite of offices. Phone number 956-3489. Feel free to call me anytime or stop by my office anytime that you can see me. If my door is open, then I'm available to be interrupted, or at least ask if I can be interrupted. So come by anytime. I have nominal office hours Tuesday, Thursday, 3 to 4, but you don't have to really necessarily come then. So just come whenever you can, and when you see me being here. A little bit about my background. I've been programming since the 70s. I started doing my professional programming in COBOL. I was creating an accounts receivable program for the Honda motorcycle company in Michigan, and went on to work for Ford Motor Company for a while. I worked on the compiler that they used to build the programs for the EEC-4, which was the first chip that was put into a car to control its engine system. It's kind of wild. I'd go to the Dearborn plant to try something out, and the engineers would say, "Oh, the chip is out in a car someplace, driving around the parking lot." They're checking stuff out. Then I went to graduate school, and I fell in love with my first programming language. Or I fell in love for the first time with a programming language, I'll put it that way, which was Common Lisp. Definitely the best programming language that's ever been designed, in my humble opinion. It's too bad we aren't all using it. The world of programming would be leaps and bounds ahead of, or technology in general would be leaps and bounds ahead of where it is now. And we'd all be having much more fun programming if we were all using Lisp. Sadly, that's not the case. So I moved over to Java in the 90s and have been using that pretty much ever since for the most of the projects that we've been doing. Java kind of, occupies a certain kind of sweet spot in the programming language universe. It does some things really nicely. The JVM is a really elegant piece of technology. In fact, what you're finding now is that people are building new languages that compile down to JVM bytecodes, because the runtime environment provided with Java is so fantastic and so much better than anything else out there that people don't want to actually try to rebuild that particular wheel. Instead, they're just building compilers that execute on the JVM, and that's kind of a cool thing. The Java language itself has a lot of nice things about it. They made a few design errors at the beginning, which kind of hampers it from being the most elegant language it could be. And it's also embedded in the kind of traditional imperative paradigm. If you're taking ICS 313, you'll learn all about the different paradigms there are. And more recently, in the 2000s, I was working in software metrics for a while, built a system called HackyStat for gathering process and product data. The last few years, I've been working in renewable energy, and we're working on a project right now for all 1,000 freshmen entering the UH this fall and living in the residence halls, called the Quicky Cup. You'll probably learn a little bit more about that this semester. And the course project this semester is going to be energy related. So I'm going to be having you guys build programs that will look at energy data and slice it and dice it in various ways. So I think that'll be kind of a fun application domain for you to learn software engineering principles. Okay, so the goals of this class are to to learn how to build bigger systems, not huge systems, not multi-million line of code systems, but systems with maybe 100,000 lines of code, 200,000 lines of code. By the end of this class, you should be pretty comfortable with the technologies and the tools and the collaborative mechanisms that are necessary to build systems that are a few 100,000 lines of code large. And that may seem daunting to you right now, because right now probably most of you have only built programs that are a few hundred lines of code or maybe a couple thousand lines of code. So my goal is to increase your span of capability by 2 orders of magnitude during this class. And of course, you don't just sit down and write 200,000 lines of code all at once and then compile it and see if it works, right? What you have to do in order to create systems of that size is to kind of incrementally grow them from a relatively small system. Well, you don't have to do it this way, but if you want to kind of be successful and efficient, you probably are better off doing it this way, starting off with a system that's much smaller, and you grow it outward from a kind of a kernel. And the basic design problem that you have is how to figure out what this succession of incrementally larger systems should be, such that you can start off with a relatively small and manageable one and then get it to this end state where it might have 200,000 or 300,000 lines of code and it's still a well-designed software system. Okay, if you don't do it right, you can end up maybe never getting to that final stage because the system kind of implodes under its own poorly designed architecture. Okay, so interestingly enough, there is this process called open source software development, which has been pretty successful in allowing that kind of building process to go on over time. And so we'll be studying that, and looking at open source software and developing software in an open source style has a number of other benefits to you, just in terms of your own self-interest. For example, when you build open source software, it's publicly available. It gives you a work product that you can show to employers that helps them understand what you're actually capable of. Okay, and this is all part and parcel of another major goal of this class, which is for you to begin developing a professional persona. Okay, so what I want you to have started when you come out of this class, and to have more fully developed by the time you graduate, is this professional presence, which consists of a online portfolio of projects that you've worked on, participation in social networks like TechHui, and an ability for an employer to see your existence, in the online sphere as a professional, capable software developer. Okay? So, what is quality? That is a term that's bandied about, and I'm going to provide a fairly non-aesthetic definition of quality for this class, but it's one that's functional and kind of, I think if you achieve it, you have generally got somewhere close to the more aesthetic definition of quality. With respect to software, there's kind of 3 things. One is that it should be easy for users to install and use to achieve at least 1 or 2 or a few of their particular goals or needs. It should be easy for administrators to be able to install, upgrade, debug, and diagnose problems and so forth. Sometimes users and administrators are the same person, sometimes they're not, but they're different kinds of activities. Thirdly, it should be possible for a new developer who hasn't ever looked at your system before to be able to download it, figure out how to build it, figure out how to test it, and learn how to actually add new enhancements. So if you've got something that's easy for users, administrators, and developers to all use, then you're getting close to a high-quality software system. Now that's pretty easy to do in the case of very small systems. It gets harder to do when the system, gets over a couple 100,000 lines of code. And so that's what we're doing in this class. We're kind of targeting the problems that occur when you get over that 100,000 line of code level. Unfortunately, for us, I won't actually ask you to write 100,000 lines of code in this class. It wouldn't be impossible, but it wouldn't be that fun, and you wouldn't get a lot of sleep. So the systems that we're going to build in this class are going to be significantly smaller, but I'm going to still require you to adhere to techniques that become lifesavers when you get to that 100, 200,000 line of code type level. Okay, so I've encapsulated this notion of quality in this thing called the 3' directives. All you Star Trek fans, you'll see where that came from. And the 3' directives for open source software are: the system accomplishes at least one useful task. Okay, a new user can successfully install and use the system, and a new developer can successfully understand and enhance the system. Very simple to say, but relatively complex in their implementation. Okay, in order to successfully accomplish, the reason why I say it should successfully accomplish just one useful task is because no system ever successfully accomplishes all of the tasks that it was designed for. If that was the case, then it's in a sense become a dead system. It can't evolve or grow, and probably isn't very interesting. So if you can get your system to accomplish even just one useful task for users, then users will start to use it, and you've got a basis from which you can start to get feedback from them about what works and what doesn't, and you can start the process of adding a second useful feature to the system, which they can then comment on, and you can start this evolutionary process going. Also, by only focusing on one useful task initially, it allows you to get something off to your users quickly, which is a big determinant of quality, in the sense that the sooner that you get feedback from your users about the system, the more likely you are to be able to design a system that users actually want to use. Okay, and in order to facilitate this first directive, we want to have standards which ensure that the user interface is predictable and conforms to their expectations. We want documentation that the users find useful, and we want it to support interaction with other systems as necessary, so that you're not having to reinvent the wheel. Okay, so getting this prime directive number 1 to happen requires that you actually have an interaction with external users. Second prime directive is that an administrator, it says user here, but an administrator can successfully install and use the system. Okay, so again, if for certain types of systems it's trivial to install and upgrade and maintain, for other systems this may be relatively complicated depending on the language and tools and so forth. But whichever way it goes, you have to have kind of standards so that it's predictable how this particular system will be built and upgraded, and procedures so that things don't get corrupted or old data doesn't become inaccessible and so forth when migration or updates occur. So we need interaction with external administrators or installers in order to achieve prime directive number 2. Prime directive number 3 is that a new developer can successfully understand and enhance the system. And this is, in many ways the hardest one of all, and the one that in many commercial environments is not really paid attention to that much. Okay, so the demands of getting something to market or conforming to a contract and so forth means that the kinds of things that are required to enable new developers to actually get up to speed with a new project are not emphasized. In open source software, it's critical because oftentimes open source software will start being developed by one group of people, and then that group of people will move on to some other kind of activity, but new people will come in and continue development. We'll be working with a system called Robocode this semester, which is a fun kind of game engine. You'll build robots and you'll fight against each other and so forth. And one of the cool things about Robocode as an open source software system is that I think there's really been literally 3 distinct generations of developers who've worked on that system. And initially, it was developed by IBM programmers. They got the project to a certain level, and then they released it as open source. And some of the Robocode gamers came in and took it over, and IBM no longer has any involvement with it, and they then took it to a next level, and then there was even a third, a new generation after that of robocode developers who've come in and done other things. And it's just amazing when you look at all the documentation and enhancements and stuff that they've added to this simple little robocode system that IBM developed initially. And part of that was because IBM did a good job of building code that other people could understand and enhance. Okay, so you can see that there's this continuing kind of theme throughout this, which is standards and feedback. Okay, we need to have standards so that people can work together, so that things work in an expected way, and so that you're not kind of tripping over inconsistencies or idiosyncrasies as you try to do the work. There's an old saying, the great thing about standards is there's so many of them. Okay, so I'm not trying to claim in this class that the standards that I will impose on you are perfect or the best or anything like that. But what I will say is that an imperfect standard, when observed by all of the people in the development group, is much, much better than 3 or 4 different standards which might all arguably be superior to the one that everybody agreed upon. Okay, so I'm going to kind of arbitrarily enforce certain kinds of standards, and when you get out of this class, you're free to go on and adopt different kinds of standards for the work that you do, but hopefully you will have learned through the experience of this class how useful it is to have a standard. So for example, in this class, all of you will work using the Eclipse interactive development environment. Even if you think NetBeans or IDEA or Visual Studio or whatever is way better, or Emacs or VI or whatever, that's a fun conversation that we can have at Manoa Gardens or whatever. But what you're going to find is that if everybody is using Eclipse and understands Eclipse, then when you get together in your group and someone's working and then you look over their shoulder and you're trying to figure out what kind of problem they're having, and they're in Eclipse at that moment, that you will not be sitting there trying to figure out, how does Eclipse work again, because you'll be familiar with that particular standard tool. Okay, and it's going to mean that you can start collaborating with that person much more successfully than you could if you were an Emacs hacker and you're a wizard in Emacs, but anybody else looking at your screen isn't able to kind of collaborate with you as easily because they're not familiar with this particular technology. Okay, and the other thing is that we need to obtain feedback from outside ourselves. Developers, it's just the nature of the game that we're blind to certain kinds of things because we are the designer and implementer of the software. Okay, so the standards, we're gonna have a lot of different ones in this class. Standards for coding, standards for packages, standards for the way that we do our technical writing and review process, and the tools that we use, and so forth. And you'll be kind of overwhelmed or sick to death or whatever of all of these different things that I'm going to impose on you in this class. But by the end of it, you'll see that using all these standards and working in a group of people who are all observing the same standards means that your trajectory, your productivity at a certain point can really start to take off, because you can start focusing on the important domain problems that you're having, and the tools and technologies are no longer getting in your way. They're kind of constraining you in a certain way so that you avoid certain kinds of problems. And they don't exist for you in this group. And then the problems that remain, and of course there will be plenty, are problems that have to do directly with the particular domain problem that you're trying to solve. And that's where you want to focus your time, is on those kinds of problems. Okay, we're going to get feedback from a lot of different places. Other members of your group, other members of the class, me, the mailing list, the different tools that I'm going to show you about. A bunch of different tools in this class which are going to provide feedback. Sometimes you're not going to like it, but you're going to have to deal with it anyway. And there'll be feedback also from some external community lists that we'll get involved with as well. Here's the architecture, and you can see that we'll start with basic capabilities, then we'll build on top these kind of vertical things, which are your standardized things from the development environment to coding standards, software review, quality assurance, testing, and configuration management. And then once we have all those things under our belt, the first thing we'll do is we'll have a midterm. But then on top of that, we'll start putting, we'll build more complicated things on top of that. And that will be kind of the second half of the class. There's several required texts: Java in a nutshell, elements of Java style, effective Java. This is optional for 3.14, required for 6.13, and then Wicked in Action, which is the web app framework we'll be using. Hopefully there are used versions of these books at the bookstore, or you can get them. Most of them you can get if you want to subscribe to Safari Online. I'm not a big I like having physical books, but it's a little more expensive. You can figure out for yourself the best way to do it. Now, every semester people kind of wonder, they come in and it's like, Java really sucks, and Python's so much better, and can't we just use Python, or can't we just use Ruby, or something like that. And I'm really sympathetic because I'm a Lisp hacker, okay, and so I'm well aware all these things that irritate you about Java. I can tell you they irritate me even more, okay, just based upon my particular background. On the other hand, okay, Java, the nice thing about Java, it has the best tool, it has the best open source tool ecosystem of any programming language, by far. Okay, if you look at the quality assurance tools for Java, they're just way beyond anything that exists for Ruby or Python or even Lisp. So my decision, and I always revisit this every year when I teach this class. I always say, should I stay with Java? Should I stay with Java? Is it time to switch? And this year I looked at it again, and I just came to the conclusion it's not yet time to switch. Another important, one reason is because of the ecosystem of tools. The second reason, and this is another big pragmatic reason, is because most of you guys come in with some Java background because you've taken ICS 111 and 211. So you at least have a couple semesters of solid Java programming under your belt. The same cannot be said for any other language. I can't, come to the class and expect all of you to have had 2 semesters of Python or 2 semesters of Ruby and so forth. And the problem is at that point, at least half the semester is going to be about intro to programming in this new language. Okay, languages you can't. I'm sorry, you cannot pick them up in a weekend. I know lots and lots and lots of programming languages, and it still takes me a few weeks, at best, to get fairly competent in a new programming language. And then there's all the libraries you have to learn and everything else, to become actually competent. So to me, since I want to teach you software engineering and not introduction to Ruby, I feel that the best use of our time this semester is to start with the language for which we all have at least some decent common level of background and facility. And one of the reasons why I'm excited that this course is now 3.14 versus 4.13 is so that I'm getting most of you right after ICS 2.11 or soon after 2.11, so you haven't forgotten the Java that you learned in this introductory sequence. So we'll see how this all goes. But I just wanted to give you guys kind of a heads up about why we have this, why I've chosen this particular language. Okay, in terms of course prerequisites, for the reasons I've just outlined, I want you to have at least a year of background in Java, and also it means that you should have taken and passed ICS 211 or its equivalent prior to taking this class. You can't take this class if you've taken 211 and failed it. Okay, you can't take this class if you're taking ICS 211 concurrently with this class. You have to have successfully passed 211 prior to enrolling in this class. If you haven't, then you just should drop this class, go back, get 211 under your belt, and then come back later and take this class. And I'm saying that to spare you pain and suffering, okay? Because it will be so painful to do this class if you haven't got 211 under your belt. I can just say that with so much confidence, okay? So please, please don't think you can do it if you don't have 211. Development environment. you know, Unix, Mac, Windows, they'll all work. You know, certain flavors of the Windows operating system are not too good, so don't use them. You know, you'll want most of the time to be connected to the network with a reasonably good connection. You cannot use the ICS lab machines, the TA machines. You know, I don't know about them currently, but in the past they haven't been that good. You can use this MSDNAA thing through the department. If you've got a Windows machine and you need Windows version 7 or XP Pro, you can get it through us for free for this class. So, you know, do that if you want. I prefer Unix or the Mac / Unix environment personally, but you know, the choice is up to you. It doesn't matter. If you want to use Windows, it's fine. The other thing that this class requires is a lot of time. If you've read the comments from prior semesters about this course, you know, that's one thing that I'm kind of unapologetic about. This is going to take a lot of time. Just like anything else that is complicated and for which you're trying to become expert at. Okay, so I'm also an outrigger canoe paddler, and I spend hours and hours and hours a week paddling because that's how long it takes. Okay, so think of any other activity. Maybe you want to be really good at World of Warcraft. You know, you're going to spend hours a week practicing and working on that particular skill. If you want to be a good violinist or guitar player, you know, or soccer player or anything, you're going to spend hours and hours and hours a week in a kind of structured fashion working on your skills, and you can't just, you know, swap it in for an hour on Sundays and, you know, expect to get good at it. Okay, so this is kind of an intense class. It's going to take a lot of time. There's a lot of things that I try to structure into the class to try to make the learning process as efficient as possible. Okay, but you know, at the end of the day, I cannot like open up your head and pour, you know, software engineering into it. It's going to have to happen through you sitting down in front of the computer and just working. Okay, so if you're not motivated, you know, to kind of, if you don't have any passion for this, then you know it won't be that fun. But maybe you'll not have passion for it now, but you'll develop it because it's such great stuff. I mean, I think this is really an awesome skill to acquire. I think that programming is an amazing thing to do. It's like poetry. It's highly creative and artistic and aesthetic. You know, and so learning all of these things in software engineering, I think, you know, enables you to focus on the poetry and not get bogged down in kind of the mechanical details. Okay, so you need a decent laptop computer for this class. You definitely you need a laptop because you got to bring your computer to class every session, because most times in class you'll be hacking. You'll be programming in class or working with another person in the class on stuff. The way I structure this class is that most of the lectures you're going to listen to at home or on the bus or, you know, wherever you want to, and then you come into class and you do work. Okay, you need a decent laptop computer, and you can get one for $500 these days. You know, so just, you know, it's very easy to satisfy the computational resources, except don't get a netbook. Okay, students try to do this in a netbook, and it's miserable for them. They're looking at a screen that's like this, you know, and imagine if you had, you know, you were trying to follow a map. You're lost in London, okay, and your map is like that big, you know, and you're like scrolling around, you know, or your view of the map is that big, and you have to like scroll around to try to figure out, you know, where you want to go. It's crazy. Okay, it's not worth it. You're going to kill yourself and get eye strain. All right, so don't have a netbook. Get a regular laptop, 15-inch screen. You know, 17-inch screen, you know, is a little bit better, but I don't know. For me, 15 versus 17 is not that big a deal. If you get up to like a cinema display, like a 27 or 30-inch screen, okay, that's better. You know, I mean, you can get some serious real estate going when you have a cinema display. But other than that, I think 15-inch screen, I've done plenty of programming in 15 inches, and you know, it's pretty good. Grading, tentatively 30% quizzes, 20% final, 50% the programming assignments. I may screw around with those percentages, but what I won't screw around with is the fact that if you get 90% in this class, you're definitely getting an A. Okay, I may adjust that downward so that 85% gets you an A. It just kind of depends on how hard things are. But if everybody in the class gets 90%, that means everybody gets an A. So you're not competing against anybody. Having somebody else, helping somebody else, and that's different from cheating, but helping somebody else do better in no way prevents you from getting a better grade. In fact, helping other people will probably be one of the easiest ways for you to learn the material and thus get a better grade yourself. Okay, so in this class, I want to, within certain constraints, really encourage you to collaborate with other people, show them your code, look at their code, work together. I want that to happen a lot. It makes the learning more fun. It makes the learning more efficient. There's very few downsides, except if people cheat, okay? Which I'll talk about in a second. This course, I'm teaching both the undergrad and graduate software engineering courses, 314 undergrad, 613 is graduate. The overall structure and sequence of events is the same. 613 folks at times will have to do more in order to achieve a certain number of points and delve into topics in more detail, okay? So there's kind of this depth level, but the overall structure is the same. The basic idea is I'm going to do very little, if any, lecturing in the classroom during the semester, because that I don't think is an efficient. You got to drive to Manoa, you got to get into find parking, got to traipse across campus, find the lecture room. That's a big pain, and it just seems like the last thing you should do once you get there is just listen to me for an hour. Okay, so I'm creating these screencasts so that on your own time you can I can be the talking head and talk and blah 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 about all this stuff. But then when you come to the classroom, you're going to be given some actual work to do, and you're going to work with other people in general to accomplish that. And I think that will make the in-class experience really valuable to you, as well as getting to know other people, which is always fun. Okay, you can't. So much of this material, is not communicated through the lectures. Okay, so this isn't like a survey class where I'm gonna, you're gonna like learn a bunch of terms or something about software engineering and be able to say, okay, the spiral model is X or Y. I mean, I will want you to actually be able to say what the spiral model is by the time you get done, but that's maybe 25% of the material in this class. It's the stuff you can get out of a book. Okay, most of the material in this class is the ability to do things. If I sit down and say, you work with this person and come up with a design that satisfies these constraints, and I want you to do it in the next 30 minutes, you should know how to sit down with that person, accomplish the task, share the work, have a shared site like in at a project hosting site where you can put the code, and so on and so forth. And that's this experiential stuff that has to be learned through the doing, and that's why I don't have this course at this point as an asynchronous or online class that people can take ALN. I haven't figured out yet how to enable you guys to get that experience. Okay, so I have these things called Quicky Quizzes, which are unannounced, closed book, closed note, in-class quizzes on the week's material. And that's ways that I incentivize you to keep up with things, or one of the ways I incentivize. The other way that I incentivize is that if you don't keep up, you're going to fail the class. So you need to keep up, but I think it helps to have these little quizzes which account for a substantial part of your grade to, A, encourage you to attend class, and B, make sure that you got the stuff covered. Okay, the Quicky Quizzes, if you listen to the screencast, absorb the material, done the readings, are generally pretty easy. I'm also going to have you be developing an engineering log this semester, which is your ability to improve your technical writing capabilities. 314 is a writing intensive class, so it's required for that, and 613 should be or is also informally. And so I think that'll be a good chance for you to improve your ability to write, which, as we all know, is an extremely important part of the process of software engineering, software development, or any kind of technical design. As I alluded to before, developing a professional persona is another key thing that we'll be doing in this class, and your persona will be created through the engineering log that you keep, the professional portfolio that you develop, the open source code that you produce and put on the web, and your participation in professional networks. Okay? I want you guys to develop this professional persona as opposed to the persona that you have on Facebook, or I don't know if anybody uses MySpace anymore, but if you still have MySpace or Google Plus, anything like that. So this is your professional presence. Okay, let me now talk a little bit about collaboration versus cheating. Okay, the definition of cheating in this class is pretty simple. It's when you take a copy of somebody else's code, either it could be a classmate's code or something you've taken off the net, and you submit it as if it were your own. Okay, and maybe there's some minor rewriting or something that you do. Okay, but essentially you are submitting somebody else's work as your own. Okay, if I see that happen, and I do check for that, I have certain tools that I can apply to help me discover that. Okay, if I see that as happening, then you're getting an F for the class. Okay, and there's no real second chances for this. The reason why I'm so hardcore about this is because it is so easy to avoid that. Okay, you've got to be trying to cheat and trying to pull one over on me to do that. If it's not the case in this class that you cannot submit as part of your program code that you got from a classmate or code that you got off the net. What you have to do whenever you do that is attribute that code to whoever the original author was. Okay, so if you found some really cool sorting module or some real cool visualization JavaScript thingy, okay, and you want to use it in your system, use it in your system, but make sure that the author that you got it from agrees, and make sure that in the code itself you say, I got this code from blah 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 blah. Okay, if you have any questions about using somebody else's code, just talk to me in advance, okay, and we'll work something out. Okay, so I want you to work with other people as much as you can in this class. That's how software engineering works in the real world. Okay, that's how it should work in this class. Okay, the only thing you have to do is you have to be upfront and truthful about the extent to which you're using somebody else's code. Now, if I have a particular assignment and you happen to just download, the solution off the net, I mean, that'd not be too terribly possible, but I mean, I guess it could happen, and you attribute it and you say, okay, this was actually completely written by somebody else, and I'm, you won't, I won't give you an F for cheating, but I might not give you a good grade because you didn't do any work. Okay, so there's a difference there. Okay, so anyway, I have not had to give anybody an F for cheating yet, thank goodness. Okay, because I really don't want to do it, and I feel like in almost all cases, people respect, people enjoy the fact that they get to collaborate. They respect what I'm trying to do, and they just are honest about what's happening. And if you're just honest about what's happening and upfront with me about it, then we can always work out a reasonable solution to whatever problem you're having. Okay, so let's just both work in good faith with each other, and it should all be good. Okay, so I hope you go to the UH course about cafe system, and I have on the home page to the site. I've got a link to all of the prior semesters of work, and I hope that you go look at those, okay? Because they have a lot of interesting comments about this class. I'm being distracted by the Skyping going on in the background. But let me show you some of the comments that other people have made that I think are particularly germane to this class. One is start early, okay? Don't get behind. Waiting till the last minute to code is not a good idea, okay? Another one is that unit testing is actually a really useful thing to do. People often come into this class not really understanding how testing works. Hopefully you come out of this class both understanding how testing works and recognizing that it's a really important part of the software development process. Reading code is really important. Following the standards is important. I'm happy to see students actually, got this. And, in a certain sense, suspending your disbelief. A lot of the things that I ask you to do, initially you might say, I don't really get why he's doing it, but, just kind of play along with me for this one semester. And at the end of it, even if you don't agree with me, at least you'll have a good reason why you don't feel this applies to your particular situation, and you'll understand when it might apply to somebody else's situation, for example, which can, as you move up in the world and become a manager and so forth, you may decide that practices in this class which you don't need to apply to your own development might be good for somebody else's, and that would be good as well. Best case scenario is, people enjoy this class and get a lot of value from it. The worst case scenario is, this is a comment from one student: taking the class from this professor is not worth the time and money. You might as well research software engineering on Google and read the book and study on your own and come off learning more than he ever teaches. If he even actually teaches is questionable. I don't know what I did to make this person so upset with me, but I can tell you that every semester I try my hardest to avoid getting a comment like this in my course evaluations. So I hope none of you feel this way at the end of the semester. Maybe some of you will, but I'm trying my darndest to avoid it. I can tell you that for sure. Okay, so the way this is going to work is that you're going to use the schedule page at the site to see which modules are scheduled for a given week. I will do my best to release the modules for the upcoming week by Friday of the preceding week. And in the module, there'll be, the screencast that you need to look at, the slides, any readings you have to do, and the assignments that are the experiential learning part of that particular module. You'll get all that on Friday, and then by the following Tuesday or Thursday, whenever that module is on the schedule page, you will be required to have watched the screencast, done all the readings by that time. Okay, and then in class we may start on the assignment or work on it in some way, or you'll have a quickie quiz on the material. Okay, so for example, you can see here, we have the module introduction is the 23rd of August, and I will have released it by Friday the 19th of August, so you'll have at least the weekend and Monday to look at the screencast and do the readings before I could give you a quickie quiz on the introductory stuff on that particular day. Okay, and then you can see that the assignment that was published in that module is due on Thursday at 8 a.m. And then you can move on through the calendar and see how the rest of the semester is. Okay, so what to do next? Definitely look through the class website, start work on the introductory module, come to class on Tuesday. Hope you've enjoyed this, and I'll see you soon.